2, 3, APNIC 50. everybody. This is the Lightning Talk session. My name is Melody, and I will be your MC for today. Lightning Talks is an exciting and quick-fire way to pitch ideas, share information, or case studies to our technical community. Before we begin, I have three things to remind you, just really quickly. Number one, be mindful of our code of conduct, published on the APNIC 50 website, and we've just shared the link on the Zoom chat box. If you have any questions or comments during the presentations, raise your hand so we can unmute you and you can speak, or you can type your questions in the Q&A button on the Zoom. Use Zoom chat box only if you have any questions not related to presentations. Last but not least, if you're feeling confident today, how about sharing a photo of yourself joining us from your home or office on Twitter or Facebook using the hashtag APNIC50. With housekeeping out of the way, I would also like to announce that there will be a soft alarm when speakers have 2 minutes left to present. So please be mindful of that. We have a fair few speakers today and we want to try to keep to time. That's all from me. Now it is my pleasure to introduce the moderator for Lightning Talks, Afifa Abbas, who is the Cybersecurity and Governance Lead Engineer from Banglalink Digital Communications. Afifa was also one of our APNIC Fellows, so it is awesome to see her now taking the lead for this session. She will introduce our speakers and also moderate questions for this session. So over to you, Afifa.
Thank you so much, Melody, for this wonderful introduction. Good morning, everybody. I'm Afifa from Dhaka, Bangladesh. A warm welcome to you all in the Lightning Talk session of APNIC 50's virtual event. As Melody stated, I'll be with you till the end of the session as a moderator. And today we have some fantastic lineups of technical talks along with some real-life experiences. And without further ado, I would like to invite our first speaker of this session, Nyamkant Buluku. She is a system administrator and planning engineer from Mobicom LLC, and she'll be speaking on implementing DNSSEC. Over to you, Nyamkant.
Thank you for your introduction. Hello. So, my screen is appearing to you.
Yes, we can see your screen, Nyamkant.
Okay. Good day, everyone. Today I'm going to talk about how I implement DNSSEC and the obstacles I face during the implementation. So my name is Nyamkant Buluku. I work as a system administrator in Internet Service Provider Company. So first I'm going to introduce briefly about MNOC.
Sorry, Nyamkant, your voice is echoing a little bit. Would you be able to adjust the audio a little bit more?
Okay.
You may be using the wrong audio input.
Is it okay now?
Can you try again? It's still a little bit echo.
And I think it's because of the room.
Oh, so it's from the room echo. That is fine. Please go ahead.
Okay. So with a lot of help of the trainers and the MNOC members, we successfully held our conference and workshop last year. And I don't want to talk about the disadvantages and advantages of the DNSSEC. It's almost a controversial part of the DNSSEC concept. So I'm just going to show you some statistics here. Only 23% of the Asian users validates DNSSEC, and in that 23, Eastern Asia occupies only 3%, and that is so low than I imagined it would be. So, and Mobinet has the highest rate of the DNSSEC validation in Mongolia. And ISPs needs to have their own cache DNS, so it's faster, obviously, and it limits illegal websites, and it provides DNS security. So we've been validating with our resolver, but I realized that last year that we also need to enable DNSSEC in our main domain. We don't place website in this domain, but we use subdomains here for our web hosting, for our XMPP server, for our mail server also. So we need, I enable DNSSEC. And configuration on cache server is so easy. You need to add just 2 rows here. And if you check here the query results, you have the AD flags. This means your resolver is validating DNSSEC enabled domains. It is authenticated data here. And I have no experience in signing this domain, so I use this guide from the ISC. Since DNSSEC is based on the public key infrastructure, you need to create 2 keys, right? And those signing keys in key signing keys, that means 2 key pairs. Since I have 2 authoritative name servers, but keep same domains, I've copied keys that are created on one server to another, and that was the problem, because I got different signage records which must be the same, and it wasn't because my 2 servers were not master and slave, they were not in sync. So I had to build master and slave authoritative DNS servers from the scratch, and so our zone transfer goes only through local interfaces. That's the security provision. And another layer of security is our server use transfer keys that cause TSIG, stands transaction signature, and we identify the master and slave servers with this key. So I created keys only on master. I didn't need to manage keys on the slave, and changes need to be done only on the master. So these 2 additional configuration row is essential for your DNSSEC. Inline signing means it automates your signing zone tasks. Whenever you change it or modify your records or your signature expired name, it automatically reassign your zone data with the keys in your key directory. Automation we use bind here, and also after DNSSEC maintain. This is for the key management automation. Check if you have new key available, or if you have expired key, it will automate the key rollover tasks here. And I also want to see the transfer logs here, so I enable the login session in the image configuration. So the last step is you need to upload your DES delegation signer records. We are part, in my case, it's data.com who manage SIM and country code TLD. My DS, I had my domain signed completely. So here are a few checking queries. You can see your public keys here. You can see your SIGs here too. And also, I get these additional files like below. DNSSEC don't touch your original record files. It just creates the another one with the contains the that signage records here. And that's because that's why it's the 7 times bigger in size. So server's performance didn't get affected much. If you see the before and after DNSSEC implementation, CPU average value only increases by 0.02%. Memory is the same. I'm sorry. Memory is the same. The memory average value only increased with the 1.8% here. And also when the signing domain procedure going, the memory isn't affected much here too. It just didn't change at all. So you can check your signing domain here. It's DNSWiz.net. It shows the full DNS hierarchy, and you can see your signing domain here at the bottom of the hierarchy. And also it's the tool that analyzes your signing domain here. And if you wanna analyze your log more, there is a queue. In your query requests, there is the identifier flags here, that's the DO bits. This is a request to your server to include any DNSSEC material. And if there is a C bit, the sender wants to answer anyway, even if the validation checks fail. So I included some of our query stats about DNS servers. So Mobinet Document DNS queries occupy 74% of the total Mobinet document requests. And we authorize 43 domain names, including Mobinet document in our name server. And that's the end of my presentation. Thanks for you to joining.
Thank you, Niamkan, for your wonderful presentation. Let's see if we have any questions for you.
Do I need to stop sharing now?
Yes, please. Okay, I believe there is no question for you from the audience, Niamkan. Thank you so much for your wonderful presentation. And I believe as DNSSEC is very crucial for all of us, so the audience who wants to implement DNSSEC in their environment, they can definitely reach out to you. Thank you so much, Niamkan.
Thank you so much. Thank you.
Having said that, I would like to invite our next speaker, Mohammad Abdul Awal. He is a Mozilla NSRC fellow, and currently he's working for the National Data Center, Bangladesh, and he will be speaking on RPKI deployment project in South Asia. Welcome, Mohammad Abdul Awal. The floor is yours now. Awal, you are still muted. Can you please unmute yourself? We can't hear you.
Yes, so can you hear me and can you see my slides?
Yes, we can hear you. We can see your slides as well. Thank you.
Okay, great. Thank you, Afifa, and hi, everyone. My name is Awal. I'm based in Dhaka, Bangladesh. Today, I'm going to talk about one of my projects that I have been doing for about an year now. And it's about the RPK deployment in the Southern Asian region. This project is actually started last year, and it's gonna end in January 2021. It was part of my Mozilla fellowship and extensively supported by NSRC. Along this project, I mean, while I was continuing this project, and I got extensive support from APNIC, since APNIC has been doing an impressive job of training people around the region on routing security, RPKI, and also from Manners, who had posted and shared their contents on their websites about securing the global routing infrastructure. There had been extensive support from local network operators group as well. My project is mainly focused on the RPKI deployment and Manners compliance or Manners recommendations. I'll show you some of the positive outcomes, and these outcomes are not because of this project only. This is a collective effort from all the stakeholders around this region who came forward and helped securing the global routing infrastructure. The coverage area of my project is mainly the 9 countries that I mentioned on the right side. It's Afghanistan, Bangladesh, Bhutan, India, Myanmar, Maldives, Nepal, Sri Lanka, and Pakistan. The goals of my project was to conduct training and workshop in different network operators group meetings, to do awareness campaigns through blog posts, and training people on the importance of routing security and how to do that. I have done RPKI deployathon with other instructors. Basically, it is a program where we do some simulation of network equipments and deploy the validators and configure the routers and try to figure out what are the advantages or disadvantages or issues currently having to configure RPKI. I've done a lot of work alongside to find out what are the issues and what are the complicated scenarios that are currently exist in the routing infrastructure in this region, and try to reach out to those people and try to fix this and help them to understand what they should do or what they shouldn't. So these are some of the activities that I have done over the years, over the last year. Very quickly, this is one of the impacts that I have after this project for 1 year. So right side. So these are taken from Manners Observatory, which updated once in a month. So there might be a slightly different statistics if you take it in real time. But I have taken it after August ended, so it's quite new, quite recent statistics. So on the right side, you see each country I have marked with 2 numbers. On the left side, the number is the percentage of valid BGP announcement before the project started, and the right side, the number at the right side actually shows what is the percentage of valid BGP prefixes at this moment in the routing table. So, for example, for Bangladesh, when I started the project, it was 29% valid BGP announcement from the country, and now it is to 83%. Similarly, the other countries as well. For India, I believe the current valid percentage of current valid prefixes is more than 20%, but in observatory it's still 13%. So I'm guessing that it's going to be updated end of this month. Right side, you'll see that this is the progress over the years of number of valid prefixes. So the project started in October. So before October, you see the progress was almost flat. And after the project started, you will see that the number of valid prefixes increased for almost 7 countries, very close to 80% or more than 80% at this moment. So out of 9 countries, 7 have done impressive job, and India is actually catching up. They're doing really good since last month, I guess, and Afghanistan as well. So I'm guessing that end of this project there will be a very good picture, including all the other 2 countries. This is my favorite. So Bhutan became the only country and the first country to get 100% valid BGP announcements. And I helped quite some of the organizations there, so I'm very proud that they did it. The right side, it's actually taken from RIPE stats, and it shows that how the project had a sharp impact on the number of valid prefixes in Bangladesh. So it started like 29% or something, and now it is about 83%. Another comparison of valid prefix increment of valid prefixes. On the left side, we have the number of valid prefixes increasing and number of invalid prefixes gradually decreasing when I accumulate all the 9 countries. And on the right side, if I exclude India because previously, before last month, there had not been much improvement in terms of creating ROAS or signing their prefixes. So excluding India, all the other countries actually in the 9 countries, 8 out of the 9 countries, they have like around 80% of the valid prefixes in those countries. Now, in terms of number of incidents happening, so there hadn't been much improvement. So why this is because RPK alone cannot secure the routing infrastructure or cannot reduce the number of incidents. We need to do validation, and we need to follow Manners recommendations as well. So now my focus is for the rest of my days for this project, and now my focus is to encourage people to do validation. And I hope this will have another massive impact in the region in terms of securing the routing infrastructure. And that's the last slide. So thanks everybody for listening to my presentation, and I'm okay to take questions. Over to you, Afifa.
Thank you so much, Awal, for your wonderful expression. So we have one comment from Sanjaya. I would like to read it out for you. Thanks for the great work, Awal, and everyone involved. South Asia is indeed leading in RPKI deployment. Please also share this at NOGS in other regions in APNIC.
Thank you, Sanjay. That means a lot coming from you. So yeah, I enjoyed working with the other NOGs, and they were very helpful. And this is, like I said, this is not only effort from one entity or one person. It's actually collective effort. So I'd be very happy to share this to other NOGs as well. Thank you so much.
Thank you so much again, Awal Bhai. So I would like to mention one thing, that the impact that you're creating by fixing the routing issues all over South Asia is truly remarkable. And you have no idea, you are truly an inspiration for all. So anybody who wants to deploy the RPKI in their environment, or any information regarding fixing the routing issues, I'm sure they can definitely reach out to you anytime. Thank you so much, Awal Bhai, again.
Yes, thank you, everybody. Thank you.
Yeah. With that note, I would like to invite our next speaker of this lightning talk session, and she is Yohani Rana Singh from University of Colombo, and she'll be speaking on location-based secure network connectivity using VLC. Welcome, Yohani, the floor is yours.
Thank you, Afifa. Hi all, I'm Yohani Rana Singh from University of Colombo School of Computing, Sri Lanka. And today I'm going to share my experience in location-based secure network connectivity using visible light communication. So before moving forward, first we'll see what is visible light communication. It is a subcategory of optical wireless communication which uses visible light spectrum for data communication. Nowadays, solid-state lighting is revolutionizing the indoor illumination, and most of the time the fluorescent bulbs are being replaced by LED due to the high energy efficiency and longer lifespan, and there are more reasons. Anyway, these LEDs are capable of switching into different intensity levels at fast rate. So this opened up researchers' mind to use this existing LED infrastructure as a communication medium. So this was highly encouraged by the radio frequency spectrum's inability to meet the ever-increasing demand in mobile data traffic, which grew exponentially in last 2 decades. Here, in visible light communication, LED is dual purpose as an illumination source as well as data communication medium. Anyway, we need to make sure only light is visible to the human eye without any flickering, and not the data it transmits. So intensity should change at faster rate where human cannot perceive. Simply the idea is when you switch on the light, you should be able to receive data. So due to the high frequency in visible light, it cannot penetrate through walls. So it provides inherent wireless communication security, which we have used here. So in our research, we are not using visible light for the total communication, instead only for the authentication purposes, especially for authentication key distribution. So all of you know Wi-Fi is the most popular wireless communication technology available today, and it uses radio frequency, and we need to get access to an access point. So here you are given some available authentication protocols like Wi-Fi protected access version 2, 3 and with pre-shared key. Anyway, we need to provide username and password, and anyone within the Wi-Fi range with the password can get access. So we cannot provide location-based network access with the available protocols. So there is no way for selectively hide the presence of wireless network from strangers, and the key distribution is the issue we have identified. In the proposed solution here, we use visible light to share the secret key for user authentication, and after that we can use Wi-Fi for data communication. So the objective is to achieve the goal with minimum alterations to the existing infrastructure. Therefore, we have slightly modified the radius server and the Wi-Fi protected access protocol too. So in a radius protocol, we have three main components: access point, radius server, and the client. So whenever a client want to get connected, communicate it to the access point, and access point relay the message to the radius server, and the radius server will send you a reply with the authentication challenge. And once you provide correct username and password, you are given the access to the Wi-Fi network. And in the new protocol, we have four components: radius server VLC module, VLC enabled LED, access point, and the client. I would like to emphasize here we are using VLC for key distribution only. And before moving to the protocol itself, I would like to introduce this prerequisite for authentication. You need to have VLC authentication enabled radius module. Here we have done it using slight modification to the radius server, and VLC enabled bulb with a unique ID and a key, and this bulb should be registered in the radius server VLC module. So we can change this later on because sometimes we need to replace the bulb. And auth key is generated by the radius server VLC module, and this is a timely key and it expires periodically, therefore we need to update it. And this VLC enabled LED should emit VLC ID periodically and auth key based on request. So here is the protocol, and same as the normal procedure, client need to request Wi-Fi access from the access point, then access point will send an identity request to the client. Meantime, this VLC bulb will emit the VLC ID periodically, and the device need to detect it and send it as the username to the access point. Then access point will relay this message to the radius server, and once the reply reaches radius server, generate the auth key and VLC key relevant to the VLC ID, and this is used for encrypting the auth key using AES in our development. After that, it is received by the VLC bulb, and VLC bulb can decrypt this auth key using the VLC key and emit the plain auth key via the visible light communication. So at the same time, radius server send an authentication challenge to the client via the access point. Then client read VLC emitting auth key and respond to the challenge. Then radius server should match this received auth key with the available auth key in the database. If they are matching, then we can provide the access. So you can see our main requirement is to provide location-based secure network connectivity. Here, since auth key is shared via visible light communication, connecting device should be within the same room where key sharing VLC bulb is available. And session timeouts we have introduced to make sure that above cycle repeatedly happen within predefined time interval and auth key expires. Otherwise, once connected, there is no need to be in the room itself. Therefore, devices need to get access to the network, need to be near the VLC bulb to have continuous connectivity. We have done this proof of concept development with a photodiode as the receiver and a LED bulb as a transmitter. So the limitations we had were like this interference from ambient light and narrow field of view. Therefore, we need to have line of sight alignment with the transmitter and the receiver, and the size of the cell also hugely based on the illumination power of the LED. And also we have done this only for downlink communication, and under future work we need to think about the uplink transmission as well without any interference. And at this development we are using a separate device as the receiver. So under future work we need to use web camera or the digital camera we have as our mobile device instead of a separate device, and also need to think about the cell layout and VLC bulb design with low cost. So thank you very much.
Thank you, Yohani, for this wonderful insight. It was very much informative and insightful. We have a question for you from Jierong Law. So, yes. Hello?
Sorry, I think I accidentally pressed on the
No problem. No problem.
Yes.
Afifa, I think that was an accidental raised hand.
Oh, that was accidental. Okay, fine. So I don't see any further questions for you, Yohani. So thank you so much for your wonderful insight. Thank you so much. Having said that, I would like to introduce our next speaker, who is Mark Brewer from IIT, and he will be speaking on diagramming at IXP to switch them all. Over to you, Mark.
Hello, can you hear me?
Yes, we can hear you.
Okay, can you see the slide?
Yes.
Okay, thank you, Afifa. And I'm going to be talking about our works is ongoing for some time regarding Internet Exchange architecture. And this work is done with IJ, University of Tokyo, with Chris Visser. First of all, when we talk about an Internet exchange point, we need to be at least 2-3 Internet service provider networks connected, and so with maybe a CDN and so, but you need to be in some metropolitan area within a city. When you're all localized, you intend to actually exchange your traffic directly between each others. This is what is the Internet exchange point. And the Internet exchange does not provide a full access to Internet, then those Internet service provider and so get always connected to the transit providers and so on. But this is a layer 2 switching fabric. This is the core of the Internet exchange. It is a layer 2 switching fabric only. Even if you get a BGP root server who allow the different BGP providers to interconnect through the star topology, through the root server itself, and exchange their prefixes. The main important part of it, it is the layer 2 switching fabric. But layer 2 switching fabric have a specific behavior today. Then that's the different things we're trying to fix. One of the things is the mark learning breach. This is based on the mechanism more than 40 years ago. And then have the switching fabric has to learn the MAC addresses and so to know where to send the different information. And it also based on this discovery using ARP or ICMPv6 ND for discovering and binding layer 2 and layer 3 information for having the different router connecting to the switching fabric to exchange traffic. Then we find this part was kind of annoying when you get actually different capacity of removing this limitation. Those mark learning and floating is hard to scale with actual solutions. Then I invite you to check is a publication that we did on rethinking IXP architecture in the age of SDN. He described the full umbrella architecture behind it. But what we're going to be talking now is a little bit different hub layers for the management that we come up on top of it. Then first of all, provisioning. Everything is done in advance on Internet Exchange. When you come up with a fiber for a new provider and so you know where it is, you know everything and all the details, and need to go for a single web interface, a single provisioning application where you're actually doing all the different things before connecting technically. Then we introduced diagramming, which is actually for designing and the one-stop function where you're actually just interconnecting and declaring the topology of your Internet Exchange switching fabric. And then you do all the testing. Everything you do need to be tested before going to productions. Then we can emulate the full control plane and data plane itself before pushing any new rules into production. This is a testing module. It is the different hardware supporting the umbrella switching fabric with Arista, Cisco, Alien Telesis, Noviflow, HP Aruba, and for the core switch in the switching fabric, We use the Tofino P4 encoded for getting the umbrella core function there. Just without going into details, but that's two different aspects of the control and monitoring. We use Faucet. Faucet is an open flow controller. It's been developed in New Zealand with a lot of contributors and very active. Faucet is the control part, and the gauge is an station specifically for the monitoring. And the dashboard connecting to gauge is Grafana. Then we have the module that we developed with the diagramming. We developed MXGraph, which is actually the open source project from draw.io. We modified it to be able to draw and do all the things. And we use IXP-Manager, with more than 130 and 4 internet exchange using it today. Is developed by INEX in Ireland for more than 10 years. And then we support and we integrate this full architecture within IXP-Manager. This is a single interface. Then we have on the left as the menu, we inside IXP-Manager, we just kind of add-on of IXP-Manager. Then you can see this is an example of a topology of an internet exchange with 18 switches. Then on the left, you have all the different switches was being provisioned. That's those blocks here. And you just have to move and place that new switch onto the diagram section. And then from there, it is done. No more CLI, only one stop process. And you're done on that part. You did your diagramming, and it actually be used for documenting. It is one step, one stop. And behind it, this is the functional diagram. Then we connect to IXP-Manager API. The MXGraph will just put in the information that's been done through IXP-Manager. And then all the topology and the Faucet config generation is done through MXGraph itself. And then we go the push on green module, who does every test possible. Turning off links, turning off switches, and so testing all the redundancy done for emulating the full control plane, the data plane, as it is in the real production. And from there, then diagramming as a new unique step once and for all. That's what we want. And then we think it's the right way to go for just getting for internet exchange the possibility to go into kind of intent-based networking, zero touch and automation, and push and green, where you do everything and testing before going production, as mentioned. We already deployed it at the Toulouse Internet Exchange in southwest of France. And we are also deploying it in those months at the Pixie in Tokyo. And they run stable for the Toulouse Internet Exchange for a while now without any trouble. We're going to be releasing a public beta version by the end of this year. And thank you if you have any questions.
Thank you so much, Mark, for your wonderful expression. So along with the content, your presentation was visually wonderful. And we do have a question for you. I would like to read it out. It is from an anonymous attendee. Whether IX nodes should be interconnected with each other within a country.
Well, this is a point regarding internet exchange interconnections. Internet exchange are actually providing service to internet service provider who usually also provide such service and interconnecting cities. Then they do not enter as competitors. If you actually interconnect internet exchange cities, you're competing with your own members or customers, and then it's not a desire. The desire is to interconnect local internet service provider nodes. Then in these cases, it's a good service. You can have remote, you can have some of the services to try to facilitate to join one another, but usually it's kind of policy. They do not interconnect much the city together. But with it, the technical presentation I show you, no problem. You could interconnect whatever distances and so.
Thank you, Mark. I hope that answered the first question. Mark, we have one more for you. and that is from Bertrand. The question is, will it be released open source?
Yes, fully open source, yes.
Okay, thank you. So we don't have any further question for you. Thank you so much again for the wonderful presentation, for your effort and contribute to back to the community.
Thank you, Afifa.
Thank you. With that note, now I would like to call up on the virtual stage our second last speaker. But first of all, I would like to apologize for the pronunciation. And that person is Oswald Ektaivan. He is an IP network engineer in Mobicom, and he will be sharing his experience on zero invalids in AS55805. So over to you.
Can you hear me?
Yes, we can hear you well, and we can also see your slides. Thank you.
Thank you. Thank you, Afifa. So I'm Oswald from Mobicom Corporation, Mongolia. I will talk about our deployment. That's the raw routing, drop invalid routes and route region validation. So this deployment starting from validator selection, and here is the agenda: approval for drop invalids and implementation and challenges. So validator selection, we choose the validator that the Routinator 3000, and that's the running on Ubuntu machine, and it's working perfectly and less memory usage comparing with the RIP NCC validator. And the Grafana and Prometheus is very useful for monitoring validator things. And after the validator installation finished, our SOC team checked the server and they recommended some security actions. So that's the my configuration. So we accept the following service all the internet is the service that HTTPS and RTP rsync, and also accept the RTR protocol and Grafana monitoring port from only our infrastructure address. All of requests denied, and also they recommended configuring KISS benchmark configuration. So here's the benchmark configuration URL is here, and also enable the HTTPS service on Grafana web interface. Then we choose the OpenSSL, install the server. Then next thing is approval from management team. So in this action, I have explained the BGP hijacks and previous world incidents to our management team, and what's the BGP hijacks, what's the max length announcement, and what's the origin is mismatch announcement, and how they impact the world internet. And after that, our management team understood and they're approving our deployment. But there wants that the customer, if complain about some website cannot connect, and then prepare the correct answers. So I have prepared the following text. That's the sorry for inconvenience. We dropped the authorized network from our infrastructure according to RFC 6811, and it's the implementing internet routing security. So implementation and challenges, and this action Firstly, we checked our border and customer edge routers. They are supporting RPK. So our routers operation system up to date, and they're all routers supporting RPK feature. And we enabled the authorization between one routine author server and border to our C router. Then start the validating and do not dropping. And it's the identify invalid routes and monitoring invalid routes. So here is some result is here. Our transit provider entity, they announce almost 300 routes, and Telia, they deployed the RPK and do not announce any invalid routes to us. And our IXP connection, that's the Deutschland exchange, they deployed the RPK and they announced the invalid routes, but these invalid routes, all this, they are remote triggered black hole announcement. And Equinix Hong Kong, they're not deployed the RPK and they're announced to us almost 1,000 routes. And our PNI connection and customer connection, they're not announced any invalid routes to us. And after that, we dropped the invalid routes. So this following rule: on border side, we dropped the invalids on BGP globally, and we set the invalid routes to that community, and future we will monitor that invalid routes. And customer side, we allowed the BGP globally and dropped the each peer. In this case, we can't monitor that invalid routes. It's disappeared from BGP table. So next thing was, I think, we used some private ASN on our system. That's the service separation, but private ASN always the invalid because it's the bogon route. So we must allow that prefix from our infrastructure, but we do not announce that priority sent to global internet. So next thing was iBGP signaling. We enabled send validation instead to other iBGP peers because it's the BGP best path selection. Valid routes prefer than not found routes. And here is some example is here. Then next thing was RTPH. It's the black hole announcement. Since April in this year, we deployed the BGP community in our infrastructure. Also, is the supporting RTPH announcement. But RPK deployment was break our RTPH. We allowed the RTPH announcement, then dropped the invalid routes. So after that, we dropped the invalid since the last day of May. We do not receive any complaint from customers. So here is also some result, a test result from RPK test. So thank you.
Thank you so much, Oswald, for your wonderful expression and sharing your real-life deployment of real-life experience on RPKI deployment. Very much appreciated, and this is something the community looks for so that we can secure our internet. I don't see any questions for you. So having said that, I would like to thank you again. And I will move on to our last speaker of this lightning talk session. Again, apologies for the mispronunciation. That is Mary Brearley from Satwik Advisors. And the speaker will be shedding light on IPv6 adoption in a pandemic. Mary, the floor is yours. Thank you.
Thank you, Afifa. Thank you, Afifa.
We can hear you well, Mary, and we can also see your slides.
Perfect. Thank you.
Thank you.
So good afternoon. And before I get before I get started, I just wanted to congratulate your region for having 4 of the top IPv6 adoption rankings according to Akamai's data today. So, so IPv6 adoption is something that we've all been working on for a very long time, some of you much longer than I have. And so I see two opportunities here. One, I see that we are in a chasm, and so I'd like to share my thoughts with you on what that chasm is about between service providers and enterprise, and how we might be able to leverage the pandemic we find ourselves in order to accelerate V6 adoption. So as I mentioned, we are in a chasm, and when we talk about adoption and the speed of adoption, obviously enterprises have been relatively slow. So on the left side, we have carriers, operating systems, mobile carriers, and service providers. They're relatively ready to go. Of course, there's still some gaps there. There are still some gaps there. However, they can handle enterprise. Where we see the slowness is on enterprise. And so why is that chasm? So my thoughts on that chasm and on the reason for that chasm is that the entities that went first had an inherent business reason to do it. So we're talking about ISPs, T-Mobile, AT&T, Google, LinkedIn, Cisco. They all had an inherent business driver to move forward. And now we're trying to reach enterprises who do not manufacture pieces of the internet. They're not manufacturing internet gear. They're not manufacturing any of the tool sets, but they are using it as a critical enabler for their businesses. And so that requires a very different IPv6 adoption story than it did with the service providers and carriers. So right now we are in the pandemic, and there are multiple factors I think we can leverage in order to cross that chasm. So right now we have the XFH effect. And by that, I mean everything that we're doing from home. So we are working from home, we're learning from home, we are getting medical care from home. And so now obviously the internet traffic has increased dramatically. I believe that the increase in traffic in Asia is anywhere from 7 to 40%. Also, we have internet in the headlines. I think it's relatively unprecedented that we have so many media outlets interested in the internet performance and its scalability. So those two factors, we don't have a lot of direct impact over. The third factor, which I think we do have influence over, is business translation. And when we put those things together, I think we can increase enterprise IPv6 adoption. So the business translation, you have probably seen that Cisco introduced a few new infrastructure roles in the last few months, and one of those is business translator. So when we talk about translating what we do into something that a business executive would take action on and actually provide budget for, which is the important part, we've always talked about performance, scalability, but those raw talking points are not quite sufficient at this point. The internet is invisible to them. It just keeps going because of all the great work that network engineers do, so it keeps going. We need to be very specific and quantifiable. We need to be specific to our company's business model. And I believe that V6 is a very good business translation candidate. So when we talk about translating V6 value to executive priorities, we need to talk about talk about V6 adoption in terms of what's important to the executives. And that's brand value, revenue, market, and strategic advantage. So when we have IPv6, we have performance at a very high level. We have performance, scalability, and security. So how do we bridge the gap between those two? And obviously there will be many-to-many relationships between those. There's not a one-to-one there. So for brand value, it may be one set of factors about IPv6 that you match, and it may be obviously many-to-many. So let's try e-commerce as a sample of that. First off, quantify the first step would be to quantify the amount of revenue that your company is actually capturing through an e-commerce channel. That's very easy to find out from on a publicly traded company. That's pretty easy to find out on their quarterly reports. Cart behavior has a direct impact on revenue. So cart conversion and cart abandonment are two factors that executives talk about all the time. So when we're talking about executives outside of IT, so the CMOs, CEO, and CFOs are very well knowledgeable about that impact. We also know that V6 generally has a faster average round trip time, and mobile is much more in the spotlight now with everybody doing everything remotely. And I believe Asia is much more mobile centric than we are even in the United States. So increments matter. We're not going to get a magic bullet. And so when we're talking about conversion rate and cart behavior, we can see that Q4 of 2018 was the highest, and it's decreased since then. And so when you're talking about the highest point it got was 3.23%, that's pretty low. And now it's going down. Of course, it'll be interesting to see what the pandemic numbers are for this. And there's been a ton of research about cart abandonment, page abandonment. This is from Google. I think you've probably seen those numbers. This is from Akamai's State of Online Retail Performance from 2017. And this is the impact of page load time. So you can see those go up when the page load times go higher. And on the conversion rates, and this is specific to mobile. So we also see that the page load times reduce cart conversions. This slide is an attempt to quantify the amount of revenue that is lost based on the time. And there are other sources for this data as well. So this data is out there. So now once you have your, we have the numbers on the number of seconds it takes for them to drop. We know that the percentage in drops in cart conversion, we know how much revenue there is. Then we can look at V6 behavior, and there's one outlier in this number, but generally speaking, the V6 round trip time is faster. So we can use those numbers to calculate a direct impact on revenue. So it's very important to get that message that it's faster, yes, but we need to quantify that and be very specific and when we apply that to our business model. So the overall message in this example is that cart conversion rates are declining. Multiple factors, obviously, for that conversion rate dropping. But site response times is a primary indicator for cart abandonment. V6 is incrementally faster, and when we're talking about conversion rates that are so slow, that are low anyway, increments are critical and are measurable. And we know that V6 can generally provide improvement in response times. So when you deliver the message, be really specific to your business model, and it's obviously we want to quantify the pitch. And when I say keep the message simple, unfortunately, when we have so much knowledge about the details of all of it, when we try to send that message to the executives, I think some of that that beautiful detail gets lost. And so for them, we really need to keep that message simple and to the point, and keep it focused on the items that the executives care about. And I think the time is right now. I think, you know, I have different opinions about the concept of a killer app, but I think if we make very specific and quantifiable business pitches for IPv6 adoption, then the pandemic just may be our opportunity, because we have the attention of executives. The internet is front and center with executives now. Mobile is obviously increasing in dominance. The XFH tech is a significant driver of internet upgrades. So we have a lot of executives looking at internet upgrades already. So why not just include V6 adoption as part of that? And obviously V6 is a critical enabler for the global economy. It's foundational. So while we are actively deploying technologies that are intended to expand the use of the internet, like 5G, you know, cloud, IoT, we need a stable addressing protocol to carry that load.
Mary, sorry to interrupt. Your time is up. Sorry to interrupt. If you can quickly finish it.
I didn't hear it. Thank you.
Thank you.
Okay, thank you. And now the executives are more sensitive than ever to the direct impact of the internet on those few factors that they do care about. Thank you.
Thank you so much, Mary, for being a strong advocate of IPv6 and sharing your adoption story of IPv6 during pandemic. We have one question from Sanjaya. I would request you if you can quickly answer it. The question is, very good story for encouraging IPv6 adoption for content provider executives. We really need this. Have you done a similar analysis for mobile providers?
Well, this kind of analysis it really is a formula, so it's not specific, and I think that brings up a great point. The more specific you are, the more successful you will be. So when you were talking about executives in finance, executives in retail or healthcare, they're not going to be building internet elements or widgets at all. So but it's a critical enabler for them. So I think in any of those instances, the more specific and quantifiable you are. Another example is digital marketing, which most companies use some of, and I don't have time to go into that today, but there are multiple stories that you can craft as long as you're very specific to your own business model and you quantify it.
Thank you, Mary, for answering the question. With that note, I would like to mention that we do not have any speakers left on this event. Thank you so much to all the speakers for your contribution back to the community. Thank you so much to all the audience for bearing with us till the end. So me, Afifa Abbas, signing off as a moderator. See you all in the upcoming sessions and wish you all a very happy APNIC 50. Over to you, Melody.
Thank you, Afifa. That was great moderation for this session. And thank you so much for our speakers. That was really good. And it was not bad on how we kept to time. Just really quickly, we have a poll running right now for you to tell us how you felt the session went. So while you're rating this session, really quickly, I would just like to announce we will have a 15-minute break. And after that, we're going to have the second session of the first security track and the open policy meeting. In the meantime, how about joining us in our social space so you can also network and socialize with other participants? We will have a Meet the Speaker session during the APNIC social space as well. So FYI on that. If you have joined the social space yesterday, please be mindful that today's link is different and you can find the new link at the APNIC 50 website schedule. We hope to see you there. Thank you very much, everyone. And we'll have the break right now.